at this example here, 1.35, and they're going to ask us to do something a little different. They're going to ask us to subtract two vectors. So I kind of want to walk us through the steps to subtracting vectors because it's a lot like those steps for adding vectors. All right, so the first step is the same. We need to resolve each of the vectors that we're going to subtract into components, same as we would when we're adding them. So we see that the A component is straight down, so there is no X component, and the Y component is the full length, 8 meters, but it's pointing down, so we need to put the negative sign on it. Do the same thing for our B vectors. So we see that in the X direction, it's 15 sine of 30, and in the Y direction, it's 15 cosine of 30. You do have to be kind of careful. Sometimes you might fall into a trap where you're like, oh, X is always cosine, Y is always sine. Be careful on that. Always look at your triangle you drew. This is why we draw them individually, so that we can do that. Now, when it comes to subtracting vectors, so traditionally we would just add the two components together, so add the x's, add the y's, and that's how we would add vectors. So in subtracting them, you can probably imagine we're going to take the A component and subtract the B component. Another way to think about this is you can think about this as A plus a negative B vector, meaning all we're going to do is we're going to put a negative sign on those two, meaning we've taken the direction, instead of pointing this way, it's now pointing this way. We've just flipped the direction of that vector. So let's go ahead and do that. So we have 0 plus or minus, however you want to think about it, plus a negative or minus a 15 sine 30. And then we have negative 8 minus 15 cosine 30. Don't worry about writing these numbers out necessarily as you're going. Like, I didn't figure out that this was 7.5 and this was something else. I just wrote them in, okay? It's not until you get to this step where you're really gonna wanna keep those numbers. So we plug those into our calculator. We end up with a 7.5 meters, and it's positive. Now, if that is not an exact number, like it is here, you are gonna wanna store that. And so when I store something, I'll typically say I'll store it as X on my calculator. So you can hit the STO button right above the on key to store that button and choose X. This one didn't come out to exactly negative 21. So I went ahead and stored that as Y. That's going to be helpful for me later on when I put these back together. All right, so our final step is we're going to take these components and put them back together and find the magnitude and direction. So what we did here is we went ahead and we took something that was in magnitude and direction, put it in component form, did our math in the component form, and then we're going to put it backwards. So we're going to take these two components and we're going to figure out what is the hypotenuse and the angle of that triangle. So in order to do that, you're going to want to draw these two. Oops, that's a negative 7.5. Good catch there. So we're going to go ahead and we're going to be in that third quadrant because both our components are negative. So I have a negative 7.5 meters, and then we have a negative 21 meters down here. So now I need to go ahead and find what is this magnitude and what is this angle here. So to find the magnitude, we're going to use the Pythagorean theorem. So we'll do x squared plus y squared, take the square root. When we go ahead and do that, we are going to end up with 22.3 meters here. Now, we're not quite done because we want to have it kind of like they gave it to us. So I have 22.3 meters at, and now I need a direction. So now I need to find that angle. And so to find that angle, I'm going to use the inverse tangent function. So the inverse tangent of 21 divided by 7.5. Now notice we have negatives over here, but I don't have negatives over there. The reason I don't have negatives over here is because the direction, the arrow, is telling me about that negative sign. All right, so I'm going to go ahead, take the inverse tangent of 21 divided by 7.5, and I get 70.35 degrees. But I'm not done yet. I need a reference for that angle. That's 70.35 degrees. Now it's kind of nice if it's north, east, south, and west, because I can say, well, this is to the south of west. 70.35 degrees, but this isn't north, south, east, and west. This is just the x and y axis. So what I do here is I say, okay, this angle is counterclockwise of this axis, which is my negative x-axis. So this is counterclockwise of the negative x-axis. And so that is my full answer there, 22.3 meters at 70.35 degrees, counterclockwise of the negative x-axis. So that is part C there. Part D says, what happens if instead we do B minus A? Okay, so you can imagine then, well, if I flip these, so now this is a positive and this is a negative, and I flip these, oh, I see that I end up with a positive 7.5, a positive 21. Okay, I get a positive 7.5, a positive 21. I'm going to get the same magnitude, it's just the direction is opposite. So instead of being in this direction, it's going to be completely opposite. So it'll be 70.35 degrees clockwise, or still counterclockwise, I guess, of the positive x-axis. Okay. Kind of just to build on that point a little bit, think about it. If I did 5 minus 3, I would get 2. But if I did 3 minus 5, I would get negative 2. It's the same size vector, it just has a opposite direction on it when you flip that around. There you go.